Hello, welcome to the module of data ingestion and management, and in this video we are going to learn about the data ingestion concepts with ETL. In this video we are going to focus first on the key features of data ingestion, followed by we'll be talking about an overview of ETL, that is Azure Extract Transform Load methodology on Azure. Then we'll be talking about the overview of ELT, that is Extract Load and Transform on Azure, and followed by a quick demonstration. So let's get started. Now, data ingestion is a major aspect of the data-driven organizations, since the tools work to extract the data from the vast varieties of the data sources seamlessly. A common problem that organizations typically face is how to gather the data from multiple sources in multiple formats. So that's why we would need to understand that how to move the data from one or more various data stores. The destination might not be the same type of data store as the source, and often the data format also could be different, or the data also needs to be shaped or cleaned before it is being loading into the final destination. So moreover, they can also contain the certain protocols to provide the secure and the rapid data transportation scenarios. Now there could be like various tools, services and processes that could be developed over the period of time to address this kind of challenges. So no matter what the processes it could be, there is a common need that's to coordinate the work and to apply some level of the data transformation on the data pipeline. So data ingestion also supports the data visualization concepts, which allows to work with a simple drag and drop features to visualize these newly ingested data sets. Data ingestion tools can also accommodate the data scalability. It can involve like allowing the companies to work with the huge data sets and to extract the simultaneously and even like add the new nodes to facilitate the parallelization. So if we talk about the overview of the ETL process, so extract, transformation and load, or ETL, is a data pipeline that is used to collect the data from the various sources. It then transforms the data according to the business rules. It loads the data into a destination data store, and the transformation can help to work in the ETL that can take place in the specialized engine, and often it involves using the staging tables to temporarily hold the data as it is being transformed and ultimately loaded to the destination. So typically the data transformation that takes place usually involves like various operations such as filtering, sorting, aggregating, joining data, cleaning data, deduplicating of the data and validating the data. Often the three ETL phases that can run in parallel, like both extract, transformation and load, can run in parallel. For example, and to save the time. For example, while the data that is getting extracted, the transformation process could be working on the data that has been already received and can prepare it for loading, and the loading process can then begin working on the prepared data rather than waiting for the entire extraction process to complete. Next, talk about an overview of the ELT process, or extract, load and transformation. In the ELT pipeline, the extract, load and transformation differs from the ETL solely in where the transformation could take place. So in the ELT pipeline, the transformation typically occurs end to end into the target data store. Instead of using a separate transformation engine, so the processing capabilities on the target data store could be utilized to transform the data. It can then simplify the architecture by removing the transformation engine from the pipeline. And another benefit of this approach is also that's to have like scaling the target data store that could also scales the ETL pipeline performance. So overall, we can say that ELT works only well when the target system is powerful enough to transform the data efficiently. The typical use cases for the ELT that falls within the big data realm, like for example, you might start by extracting all the source of data to the flat files in the scalable storage such as Hadoop distributed file system, an Azure blob storage, or an Azure Data Lake Storage Gen 2 or ADLS Gen 2 technologies such as like Hive, Spark, Polybase. All this can be used to query this source data. Now the key point is that with ELT is that the data store could be used to perform this transformation as the same data store where the data could be ultimately being consumed. The data store that also reads the data from the scalable storage instead of loading the data to its own proprietary storage. So this approach can also skip this data copy step present in the ETL, which often can be same like the time consuming operations for the large data sets. So in practice, the target data store could be like a data warehouse using like a Hadoop cluster, or in general it could involve like a schema that can overlay it on the flat file data at the query time and can be stored on the table, enabling the data to be queried like any other table in the data store. They are referred to as an external table because the data doesn't reside in the storage managed by the data store itself, but also on some external scalable storage such as ADLS Gen 2 or Azure Blob Storage. So typically the data store not only just manages the schema of the data but also applies the schema on RAID. So like an Hadoop clusters using Hive could also describe the Hive table, where the data source can effectively utilize the path to set the files in HDFS. It could involve Azure Synapse, it could involve Azure Polybase that can achieve the same results. And the final phase of this ETL pipeline is to typically transform the source data into the final format that could be more efficient, like for the types of the queries that needs to be supported. So the data that must be partitioned, ELT might be optimized that for the storage formats like Parquet that can store this raw oriented data in a columnar fashion and can provide the more optimized indexing. So typically, let's have a quick demo on the data ingestion process with ETL. So for this, let me go to the Azure portal first. So here, once we go to this Azure portal, so here I am in my Azure portal, where I have just also provisioned very quickly that an Azure Data Factory job. An Azure Data Factory, as discussed over here, that it's a data orchestration, it's a managed data orchestration platform that can help to build like end-to-end ETL and ELT pipeline through the data ingestion capabilities. So once we provision a data factory, we could be able to just being able to see that the data factory studio that is being available, that's to we can start from there, that's to build out the various kinds of data pipeline. We can monitor it, we can edit it, we can also see that the overall pipeline running process, the activity running process, the integration runtime, the trigger details, and all this different sources. Now once you click on Launch Studio, so you'd be landed over here, that is in your Azure Data Factory Studio itself. So this is basically the home page of Azure Data Factory Studio, where we can start, that's to ingest the data, that's to copy the data at scale or at once on the schedule. So once you just click on ingest, so you'd be just being landed to the properties pages, and you can use the copy data tool of ADF to perform the one-time or scheduled data load from 90 plus different data sources. And this wizard can help you to load the data from the various settings using the copy data tool methodologies. You can build out this data ingestion from the various different types, from the 90 plus different data sources, and you can choose over your sources as per as your requirement. So you can just choose over your data sources like the various kind of data store sources, like from Azure level like Blob, Cosmos DB, Data Explorer, Data Lake Storage, Azure SQL databases, Azure MySQL databases, Azure database for Postgres, Azure Databricks, other databases like Amazon RDS for Oracle, for SQL Server, for Redshift, for Impala, for Google BigQuery, Hive, MariaDB, MySQL, PostgreSQL, Presto, the SAP databases, Spark, Teradata, on file system databases like HDFS, HTTP, SFTP, on the generic protocol based datasets like REST, OData, ODBC, on NoSQL basis like MongoDB, Cassandra, on services and apps basis like Amazon Marketplace, AWS Marketplace, Dynamics 365, Dynamics CRM, Jira, Magento, PayPal, Salesforce, SAP, Snowflake, all these various kinds of the data sources as being there, through which you can just ingest the data and build the end-to-end ETL or ELT pipeline on Azure Data Factory. So as part of the demonstration over here, I have already created a sample data factory over this period of time. So if I just go back here to my Data Factory Studio, So you would be able to see here that's the options that is being available. That's to start with. So here for example, let me launch here my studio for the Azure Data Factory, and let me show you a very quick ETL pipeline that we can build out. That's while we have been transferring the data, or end to end we have been performing the data orchestration from Azure SQL database to Azure Blob Storage. So here I have my sample data pipeline that is being available, that where I have just copied the data from Azure SQL database to the Blob Storage account, and here this is what this particular pipeline looks like after the data got transferred into. So here that is actually involves the job, the copy data job that is actually being responsible for transforming the data. Here goes the two data set, that is my source data set, which is basically nothing but an Azure SQL database through which that the data got transferred into. And this is my destination data set that involves an Azure Blob Storage, where the data that is got transferred in the forms of typical ETL operations, that typical ETL copy data operations, and that I have used this column delimiters like as a CSV column delimiter, the row column delimiters. The encoding is a default encoding type that has been used so far, and after this data that is being transferred here, this copy data tool that is actually being helpful, that's to define over this end-to-end data pipeline details. So here, like if you see over this the overall JSON code for this pipeline, so here you could be able to see that it involves like the various activities details, like the copy data activities that involves like the retry timeout, retry intervals, the user property details for both the source and destination tables, the type properties like for Azure SQL's data sources, the limited text file sync details, the validation data consistency details, the input file dataset details, the output file dataset details. So all these different kinds of data details or the code level details that it is basically being consist of. And now if you come over the next sections, that is called as the monitoring sections for this ETL pipeline. So now under the monitoring tab, if you just click over the pipeline runs, and under the sections of the triggered, if you just select over your pipeline and if you just click on this pipeline, so you could be able to see that the various copy data operations that has that has been actually being performed on this pipeline, that's while transferring the data from Azure SQL database to Azure Blob Storage. If you just click on the monitor, so here you can see that end-to-end details of the ETL data jobs that performed the data transformations and the orchestrations from the source of Azure SQL database to Azure Blob Storage. So you can see that overall data read operations, that the total amount of data received from the source data store, including the data copied in the run, then data resumed from the last failed run, to data written operations, while the actual amount of data that could be written or committed to the sync, the data could be different from the data read sizes, as it relates at how much data could store this data, and it could involve into like the number of rows read to the files to be written. It could involve the basic throughput of the data. It could involve like the starting times, that the data integration units, the queues, the transfer details, and all this kind of informative details that it could be involved into. And you can also able to find out that overall the ETL pipe jobs. So there is a rerun options over there in this ETL pipeline for this data flow job that being involves end-to-end into this monitoring operations for this data pipeline. So in this video we have covered end-to-end how we can just being able to perform that's end-to-end into this data transformation operations and data orchestrations also we can do in terms of the ETL jobs building. Now since if you just check over here in this Azure Blob Storage, that where this output data that has could be stored into, so under the container sections of this Blob Storage, if you just check over that all this data files that has actually got transferred from Azure SQL database to Azure Blob Storage through this Azure Data Factory ETL pipeline, and through the data ingestion from Azure SQL database to building up of this ETL pipeline, and then transferred the data to Azure Blob Storage. So it is just being an example of end-to-end example of how to build the ETL pipeline through Azure Data Factory, in just being ingesting the data through Azure SQL databases, and then just performing end-to-end extract, transform, and loading operations through Azure Blob Storage. So in this video we have covered end-to-end how to perform the data ingestion with ETL services. I hope this video has been informative for you, and I look forward to see you in the next video. Thanks for your time.